This video is about reproducing the 7 digital logic functions in Excel using only the NAND function. The 7 functions are best understood by looking at the basis functions AND, OR and exclusive OR. We take as an example a mother saying to her child, "You can have a drink or an ice cream." Then we penetrate the logical meaning of the statement to match it correctly to one of the 7 functions. 0 means no, and 1 means yes. For the AND function we have the statement, "You can have a drink and an ice cream." No match. For the OR statement we have, "You can have a drink or an ice cream or both." Still doesn't define the intended meaning of the mother for one or the other, since it includes both. At first glance, the exclusive OR function seems to capture the intended meaning. However, the mother did not explicitly state that neither a drink or an ice cream was an option. A further 3 functions can be produced using the invert or not function. Not is simply the contrary statement. If the input is yes, the output is no, and if the input is no, the output is yes. The first of the functional statements created like this is the not AND, or the contraction NAND. In this statement, neither a drink nor an ice cream is included as a possibility, and the case of both a drink and an ice cream is excluded. This then is a logically correct function describing the mother's intent. The NOR function says the only valid outcome is no drink and no ice cream. Disappointment. The XNOR function says that the child can have neither or both, but not one or the other. This is a complete list of the digital functions used in a modern computer. There are no more than these 7. Not only does the NAND function stand out as the correct interpretation of the mother's statement, but also each of the other 6 functions can be constructed from a configuration of NAND functions. Since Excel has no NAND function, we begin by constructing one. To create an inverter, we simply type equals not and then the cell name we want to invert, in this case F10. A 0 produces true and a 1 produces false. If we need a digit returned, we use the relationship true times 1 is equal to 1 and false times 1 is equal to 0. So for example, we just type equals G10 star 1 in H10. It makes things clearer if we use conditional formatting, so the resultant H10 is light red for 1. To combine functions in Excel we use brackets. The same rules apply as in algebra. The inside bracket is executed first. The combination of not and AND becomes equal, not, open bracket, and, open bracket, E8, E10, close bracket, star 1. The astonishing thing about the NAND function is that it can be used to produce all of the other 6 functions. In theory, this means that we can create the entire logical component of a computer from NAND functions. For the first example, we turn a NAND into an inverter by simply tying both legs together. so F9 is always equal to F7. This allows only two inputs, since producing different values from A and B is impossible. Since XL uses relative addressing, once we have made one NAND, we can simply copy and paste as many as we require. You can see the bottom cells are different from the top ones, but correct for the new position. As a second example, an OR function is created from 3 NANDs. The legs of the red and green NANDs are tied together. The inputs to the blue NAND are given the output addresses of the red and green ones. So the configuration is correct for an OR function. For a third example, we create an AND from 2 NANDs. The output of the blue NAND, E8, is connected to the input of the red NAND, G7. Then the legs of the red NAND are tied together to create an inverter. And we have an AND function. The exclusive OR in the example is a drink and an ice cream, but not both, and not neither. It is simply written A and not B, or B and not A. The circuit created with NANDs contains 2 NOTs, dark blue, 2 ANDs, blue and red, and an OR, red, green and blue. Notice that there are 2 sets of NAND inverters in series. If the input to these configurations is 1, the output is 1. If it's 0, the output is 0. They achieve nothing and can be eliminated. In this sequence, the 5 remaining NAND functions are shown together with the corresponding cell programming. The truth table can be checked to verify it's an exclusive OR made entirely from NAND functions.